Choose your fighter.
Lightning inspired. Fight.
Is an array of rows and columns enclosed bracket, enclosed in, well, in brackets actually. Inside these matrices, no, let me not use inside. These matrices are made up of what we call elements. All right. For example, you could have numbers, letters, names, etc. All right. So inside the brackets, we have what? Numbers, letters, names, etc. All right. This will explain to you why it's called a super matrix. All right, so I'm trying to get this number here to be, so this is what we call a 2 by 2 matrix. All right, so
yes, I saw you speaking.
All right, just mute your mic. You don't have to say shh, just mute your mic. All right, so we call it a 2 by 2 matrix. Now, what does this 2 means? All right, so this 2 represents the, please write it here because it's kind of difficult for me to type it. So this represents the number of rows. So basically what this is telling you that this matrix have how many rows? 2. All right, so those are the rows. The rows go across. So the first number tells you the number of rows. What do you think the second number tells you?
Column.
Right, number of columns. And so we have column 1, column 2. And we have row 1, we have row 2. All right. So this matrix has 2 rows and 2 columns. So we call it a 2 by 2 matrix. All right. And this 2 by 2 is called the order of a matrix, or the dimension of a matrix. So if I say, what is the order of that matrix? 2 by 2. What's the dimension of that matrix? 2 by 2. No, it just happens that this 2 by 2 is actually called a square matrix.
Sorry to interrupt you. You see the part of your right order, sir? I'm not seeing the the other words below it because it cut off. Is it possible you could rewrite it or something, please?
All right, no problem.
Thank you.
This is called dimension. All right. So the order of a matrix or the dimension of a matrix tells you what? The number of rows and the number of columns. All right. Now, why do you think this matrix is called a square matrix?
Because you can form a square from
Yes.
the 2 rows and okay.
Thank you very much. Yes, you're absolutely correct. You can actually form a square. If you look at it, well, notice you get 4 equal sides. Can somebody tell me the order of a matrix, of another matrix that would give us another square matrix? So a 2 by 2 will give us a square. What other order would give us another matrix, square matrix?
Rectangular.
4 by 4.
4
2
by
by
4.
3.
4 by 4. Janet, I say square and you talk about rectangular. No, that wouldn't work. You know? What about a 3 by 3? All right, so all these will give you what? A square matrix. Yeah, because look, the numbers are even, not true? In other words, both numbers have to be the same in order for you to get a what? A square matrix. So a 5 by 5 will also give us a what? A square matrix. All right? All right, now you see 4. So this is column 1, you see? Column 2. Coming down is column 1, coming down is column 2. Going across is what? Row 1, and that is what? Row 2. All right? Can somebody tell me what is the combination of rows and columns to get 4?
Would it be where you have the 4 to the 8?
No, all right, let me give you an answer. 4 is actually at R1, C1, or C1, R1.
Oh.
Yeah, so if I ask you to identify where element 4, because remember, these are the 4, 6, and -9 and 88 are called what? They are called what? Elements. All right? And if I say to locate element 4 is located where? Row 1, column 1, or column 1, row 1, doesn't matter. How can we locate 88? Where is it at?
Row 2, column 2.
Row 2, column 2. Yeah, as easy as that. All right. Any questions? All right. Let's look at.
Sir, good evening, sir. Green here.
Yes.
I'm just logging on. Sorry about that.
Mm-hmm.
Could you explain what is on screen?
All right. Let me just quickly explain to you and others for those joining. All right. So we're looking at quickly. We're just looking at I don't want to move the screen because if I move the screen, the writing is gonna remain the same. All right. So we're looking at matrices. So a matrix is an array of rows and columns enclosing brackets, and these matrices are made up of elements, for example, numbers, letters, names, etc. So basically, a matrix is just an array of rows and columns. So see there, we have row 1, row 2, column 1, column 2. All right, now the order of a matrix tells us the number of rows and the number of columns. So this 2 by 2 means that the first number, it tells us that what we have what? 2 rows.
2 rows.
And the last number tells us how many columns. So we have 3 columns. Sorry, not 3, 2 columns, sorry. So we have 2 rows and 2 columns. I know where 3 come from. All right. So this is column 1, column 2, row 1, row 2. So then now I ask the question, how would you locate 4? 4 is what? 4 is located at row number 1 and column number 1. If I say locate 88, 88 is at what? Row 2, column 2. Follow now?
Yes.
All right, you sure?
Yes, I got it.
All right, very good. Okay, so I'm going to erase. Anybody writing this thing off?
Yes, sir. 1 second.
All right. Who wants to tell me the order of this matrix? How much rows it have?
4.
1, sir.
All right, so 1, 2,
Two.
3, 4. So it has 4 rows and how much
And
columns?
1.
And 1 column. You're correct. So it's a 4 by 1 matrix. Everybody see that? It only has what? 1 column. But 4 rows. 1, 2, 3, 4. So this matrix is actually called a column matrix. Why is it called a column matrix?
Because you only have 1 column.
Yeah. So it's called a column matrix because it has what? 1 column. All right, what's the order of this matrix?
1 row.
Mm-hmm. 1 row. Mm-hmm.
4 columns.
1 row matrix, miss, sir.
Well, you wouldn't say 1 row matrix. You would just say what? Row matrix.
Okay.
Yes? All right.
1 row.
No, man, you're not going to say 1 row. You just say it has 1 row, but they don't call it 1 row matrix. They call it just row matrix. All right?
Okay, sorry.
But like, for example, if I want to have 1 hand, you say, oh, it's a 1 hand man that. you don't say it's a hand man. You have to say 1 hand. Yes. If you ask some woman these days, no, would you marry a man with 1 hand?
Yeah.
Boy, you know, life must be rough for people like those. You know, growing up, like you know, like for example, you can't walk. You know, or you can't see. Boy, but then yet again, you have people that are healthy, who can walk, who can see, and are work gonna kill people, not true?
Exactly.
Mhm. All right, so we have what we call a row matrix because oh dear, this thing come up again. I don't. Anyways, all right, so
Sorry,
we call it a row matrix.
Sir, somebody that has a one hand, you could never I hear them complaining, saying, I wish I had two hands. Never. They never complain. Even the blind. You never hear they said, I wish I could see. No. Have you ever heard that?
Well, not
Because they
really.
depend on other ways and means of survival. They
Mhm.
don't look on the disability as it is in our eyes.
Mhm.
What do you think about that?
Well, the thing is, I wouldn't know. I've never been around persons like
Oh,
that. So you know, but you're correct when you say they do depend on others. You know,
yeah.
I've
Yeah.
seen them, but I don't know anybody personally except for probably Stevie Wonder. Well, I don't even know Stevie Wonder either, but you know, um, hmm.
Yeah.
All right. So we have what we call column matrix, and we have something called what? Row matrix, and we have something called what? Square matrix. All right. And we have a few others, but we're not gonna go into that. You know, we have something called a null matrix. Let me just tell you, a null matrix. Null matrix just means is what? Everything in here is what? 0, 0. All right. And for our purposes, for 60 purposes, they always seem to use 2 by 2 matrices. So for 60, most of the time is what? 2 by 2. All right. We are going to move on. Yes, Double, we have something called a diagonal matrix. Yeah, man. There. I gave you some notes, not true? Yeah, so you can read the notes as you go along and use it as a guide. But I can't locate my notes right now, so I'm just using. Yeah, you have something called a diagonal matrix. All right. Just to point out to you another thing though that a diagonal matrix are first of all, what is is a diagonal? If I give you a rectangle like this, and you're to draw crosses like that. These two lines, these lines, they're called diagonals. All right. And just like in a actual plane figure, like a square rectangle where you have diagonals, a matrix also have what? Diagonals. All right. So those are the what? Diagonals.
Oh, so sir, when I was answering, saying you put the 4 with the 88, that's the diagonal. And
Well, maybe that's what you're talking, but yes, yeah. Those are right. As a matter of fact, well, you wouldn't have a diagonal for this because it doesn't work for that. So you find that square matrix only have what? Diagonals. All right. And let me just say something to you also, is that the first diagonal, is 4 and 88. And it's called the leading diagonal. So this one here, the one that's falling to the left, is called in the leading diagonal. And this one here on the right hand side is called the non-leading diagonal. You get that? Let me say it again. Each matrix, each square matrix, if you're to make a cross in each square matrix, all right, they have something called diagonals. All right. So if you're to make a cross, the cross that drops to the left is called the leading diagonal. So 4 and 88, that is what? The leading diagonal. And the other diagonal is called the non-leading diagonal. So this is the leading diagonal, and this one is the non-leading diagonal. 6 and -9. All right. Any questions so far? Is everybody clear? Any concerns?
Login, sir.
All right. All right. So let me clear all of this. Let us say we have this this matrix here, right? What I'm saying, you see, just like when you have a rectangle like this, all right? So look at this thing that's bothering me right here. If you were to draw some lines across it, those lines are called what? Diagonals. No, a matrix also have diagonals. So these two numbers here, those are diagonals. What we call is the what? The leading diagonal. And the other set of numbers is called what? Non-leading diagonal. All right? You follow now?
Yes, sir.
All right. So 3 and I believe it's 1 is called the leading diagonal, and -2 and 1 is the what? Non-leading diagonal. All right. Anybody all right a while ago?
Yes, sir.
All right, go ahead. Continue. Tell me when you're through, please.
Can erase them, sir.
Okay. All right. So we're gonna move on. We're gonna look at adding, subtracting, and multiplying. Oh, that's not look right. Multiplying matrices. Fine. Okay, so adding, subtracting, and multiplying matrices. So what I'm going to do, is this thing bothering you? Is it in the way?
Yes, sir. And I'm into that page.
Oh dear. All right, so when we are adding and subtracting matrices, we do so entry by corresponding entry. What does that mean? You see the 4? All right. So when I finish add these two matrices, I'm going to end up with another 2 by 2 matrix. And what we do, we add this 4 with the 0. So the 4 plus 0. And then what? 6 plus
3.
No, look carefully.
Next to 3.
Yes, you have to be careful. Mr. Brown, Mr. Brown, open Mr. Brown. It's like that's deja vu again. Some of you owe the man on a run with the man money. And now Mr. Brown will come back. Go haunt you. But I hope we can get through this, all right? Don't worry. All right, everybody saw I set it out? Or you add matrix? Come on, just if you look, it's the 4 will go with the 0, 6 go with the 3, 5 go with the 1, etc., etc. So that's the outline. And then all we need to do now with class is just do what? It's just add them, not you? Yeah. So 4 plus 1 is what? 4. What's 5 plus 1?
4 plus 1, sir.
6. How you work out this one?
Sir, go get -3. So you owe Mr. Brown $6, you give money $3 out of it. That's what I say.
You're gonna end up with a positive 3.
All right. How you? Well, no, Kristen. No, Kristen. No, it's if you notice, the two signs are together, not true? So when the two signs are
I had
together,
a positive 3 to 3.
Negative.
right? You get a negative. So you say when signs are together, we use the rules of multiplication. So these two symbols here will eventually give you one symbol, which is a negative, because we're using the rules of multiplication. How much 3 is from 6?
3.
3. All right. But this one, no, yes or no? A trouble, Trouble.
We get -5.
That's again negative.
Very good. Very good. If you got -5, it's correct.
So
right. So you write about the -3. A positive and negative gives you a negative. Well, notice. All right. Sorry about that. So a positive and negative will give you a negative. So we notice when the signs are together, we use the rules of multiplication. But then now, when you use the rules of multiplication, you get two negatives there. And that's about what? Or Mr. Brown, $3. Or Mr. Brown, how much? $2. So in total, you owe Mr. Brown what? $5. And that's the answer. And this is the sum of A plus B. Any questions? All right. No.
I saw one thing, so you say when you have two signs, you use the rule of multiplication. I said right.
Yeah, when the signs are together, we use the rules of multiplication. So for example, look, if I say 3 subtract 3, you use the rules of multiplication. But if I have -3 plus 6, the signs are not together. So we use Mr. Brown. Or Mr. Brown $3, and your mother gives $6. If you have Mr. Brown, you're going to have money in the show. But signs are together here, so 2 negative gives you a positive. We're good? So what I wanted to do is to try work out B plus A and work out part 2 also. B subtract C, C subtract B. Remember, same way you add, same way you subtract. I'm gonna give you, all right, you know what? I'm gonna be nice. I'm gonna give you 5 minutes for each question. So 5 minutes, 5 minutes, 5 minutes. All right, so remember, the same way you add, same way you subtract. I'm just gonna copy this. All right, I'm just gonna change over this number. So basically, it's gonna be 0 plus 4. All right, and then this one over here would be what? -3 plus 6. This one down here would have been, the 1 will come in front. That's 1 plus 5. And then this one here now, you'll get -2 plus -3. All right, equal, I'm just gonna copy this. As you can see, we get the same thing, right?
Yes, sir.
Right, because I mean 0 plus 4 is 4, -3 plus 6 is 3, 1 plus 5 is 6, and this one on here is also -5. All right, so the conclusion, is adding or addition of matrices obey the
See.
commutative law. There's a law. All right, it's called the commutative law. So when you spin around numbers, all right, when you add in numbers and spin them around, you end up with the same thing. The ability to do that and get the same thing is called the commutative law. All right, any questions? Let's look at part 3. Oh, part 3 says what? Part 3 says, where is
B
it?
minus C.
Right, B, this one here, not true. B minus C. All right. Let me just copy and paste it. Boy, I'm just using up this technology thing here just to avoid work. B minus C. All right, so what we have here is the B matrix and the C matrix, which I'm also going to copy. So I'm just going to do that. All right, now what did I say? Same way you add, same way you what? Subtract. Right. So, boy, this box is just annoying. I think I sent a message to my students, but I didn't put anything there. I'm gonna call if she's available. All right, so we're gonna set this thing out, not true? So 0 subtract 5. All right, and then you're gonna have
1.
no, I'm gonna cross. So it will be -3 subtract 5.
Right.
And then down here, so you're talking about that one. 1 minus 0.
Right.
And then you have -2
Minus -6.
minus, right, -6. All right. All right. So, I mean, this is just, that top one is just -5. That one is just what? 1. Your O and your O. All right. This one here, so these two negative here, so will give you a what? A positive, not true?
Positive. Yes, so it would be 4.
So you have, right, so you have -2 plus 6, which will be positive 4. All right. All right. Okay, so what we're doing right now, hold on, you know, so A plus B and B plus A is on a one thing, not true? So that shouldn't be part 2. That is just one question. So this is just part 2. So we're going to look at C minus B now. All right. So let me ask a question. All right, I have 5 subtract 3. What is 5 subtract 3?
2, sir.
Yeah, but what if I spin it around?
3 subtract 5.
Mm-hmm.
Gonna be negative.
Right.
2.
So what's the conclusion? They're not equal, not true?
Right.
So when you notice, when you flip around numbers when subtracting
Get a
integers, when you, well, yes, you get a negative, but also when you flip them around, they're not equal. You see that? So when you have two numbers and you flip it around and you're subtracting, they're not equal. But when you do the same thing with the addition, they're equal. You follow? So what is the conclusion about subtracting integers? They do not obey the commutative law. You follow?
Yes, sir.
Right. Them rude. Then disobey. All right. So that's what we're actually investigating here. Would you agree? In terms of matrices. So, well, this should be C minus B, not true? All right. So what happened? We have B minus C, and we get this. And then we have C minus B. If we get the same thing, then we say what? Subtraction what? Obey the commutative law. But if you flip around these matrix and get something different, then you'll say it disobeys the commutative law. Did anybody get a chance to work this out?
No, sir. I didn't finish.
All right. Anybody else?
Yes,
Any-
sir.
All right, hold on.
Yes,
Hold
sir,
on.
I do.
You do it?
Yeah.
All right. Did you get that? Did you get that?
Yes, sir. Yes, sir. I get
Yeah,
that.
man. If you get that, it means that you're correct. Very good. All right, excellent. So what you notice? The numbers are the same, but what? The signs are different, not true? Right.
Yeah.
Yeah, but technically they're different, not true? Yeah, that's the different. So what you notice when you flip around the values, the matrix, the numbers are different. All right. Do you guys want me to work it out? Or
Work it out. Yes.
work it out? All right, no problem. C subtract C subtract B. Well, if you ever see my screen, it's so confusing. There's so, as a facilitator, I'm seeing so many boxes in front of me, and then no, this thing is popping. All right. All right, so I'm just gonna all right, so this is gonna be 5 subtract 0. Yeah. And this is gonna be 5 subtract 0. All right, which will give you a plus. Let me put a bracket there just to separate the two thing. And this is just 0 subtract 1. This is -6 subtract -2. And you get this. All right, so 0 from 5 will give you 5, 5 subtract 3 is 8. 1 from 0 is -1. And this down here, so is -6 plus 2, which is -4. So what's the conclusion? That subtraction of matrices does not obey the commutative law. All right. Any questions? So subtraction of matrices, what? Does not obey the commutative law. All right, are we good? Any questions? All right. None so far. All right. Somebody got kicked out. If you got, all right, I'm not the host. Somebody sent a message. Contact the school. All right. There's somebody there. Yeah. Yeah, if you got kicked out, somebody's actually there. You know, they may not be there physical at the school, but someone's actually monitoring what's happening here. I don't think they're gonna sit down and actually just look at the screen. I think what they do, they'll just admit students, registered students, and see just check to see one who's on, and then when it's close, when it is close to the end of the program, they just log out. All right. So we have done part 1, part 2. Let us look at part 3. All right, and part 3 is pretty simple. All right, so it says 4C subtract 2A. All right, so part 3. Class, what do you think? All right, C is this matrix here, right? This matrix here is C. And that's 4. Subtract 2. Um, 2A. Class, what do you think 4 times this matrix mean? What do you think it means?
You multiply everything in the bracket by 4.
Right. You're going to multiply every element by what? By 4. And 2 times this matrix means 2 times everything in there. All right, so that's what you're going to do. You follow, class?
Yes.
Right. So this, all right. So 4, 5 is what?
20.
Right. And that's also what? 20. That's 0. That's what? Negative what? 24. All right. All right. So I want you guys to work this out from here. Oh, I need to say something to you. Before you work it out, right? All right. Now, it's anytime you have something like this, look at this. Look at this negative, the subtract 2. It's very tempting to say negative 2 times negative 3 gives you positive 6. But don't do that, yeah? Don't do that. What you do, just multiply the number times everything inside here and leave this sign alone. Leave it for last, yeah?
Repeat that, sir.
Yeah, I'm saying if you look at my screen here, let me put on the spotlight. Right here, so this looks like negative 2, not true?
Yes, sir.
And this is negative 3. So I'm saying it's very tempting to say negative 2 times negative 3 gives you positive 6. But don't do that. What you do is that you're going to leave this sign for last. So it's actually just 2 times what? Negative 3 to give you negative 6.
Okay.
All right? Are we clear? All right. So please work this out and tell me what you get. You know, what's the answer? Who wants to go ahead?
Sir, it would be 12, 8, 8 over there. And would it be negative 10 and negative 18? Or positive 18? So I'm confusing the command.
Yeah, that's correct.
Negative, okay.
All right. So let me do the work, the setting out. So it's just, anybody have any problems with that one?
No, sir, that's what I got as well.
Very good. Very good. Let me tell you something. Maths takes a lot of practice. You know? Let me tell you, you have to practice a lot, you know, just so that you can remember all this up, you know. Would you agree? Yes, you have to practice. Let me tell you, you have to practice. You know why I said that? One time, you know, one student, not you guys, you know, I can't remember if it's a he or she, I think it's a she was for example, the person was working this out, right? So instead of saying 20 subtract 8, you know, the person put 20 subtract 20. They start to work out inside the matrix. Killer did and I said, sir, what you do? At 20 subtract 20 gives 0, sir. Sir, you're yeah, man, you have to practice. All right. So 8 from 20 gives you 12. 12 from 20 gives you 8. You know, 10 and etc. etc.
Sir.
Yes.
One question there, sir. You see that part where the 8, 12, 10, negative 6. Which part of the define A part you're working out? Let me lost.
Well, this is A, right?
Yeah.
That's A, right? So the question says, and this is also A, not true?
Yeah, understand the 4C minus the 2A part, but when you reach taking out, after you get the answer 20, 20, 0, negative 24 part over there, down the bottom there, I see you're taking out.
Down here, sir?
Yes. So I was asking the 8, 12, 10, negative 6 is from where?
Oh, you mean where did it come from?
Yeah.
It came from right here. From this. This is 8 from 20 to give you 12. Is it? And this is 12 from 20 to give you what? 8. You get it? You follow?
Yeah, me understand that, sir. This part in the middle here, the 8 and the 10 and the 12 and the negative 6 is part of where you I see you're taking it away from the 20, 20, 0, negative 24. I was saying where that come from.
Oh, where the 8, where this come from?
Yes.
All right. So do you understand where this come from?
Yeah, it's the part where you work out for 4C minus 2A.
Right.
Mm-hmm.
Yeah, so the 2A, not 2A, not 2 times 2A is 2 times 4 to give you 8.
Oh.
And 2
Okay.
times 6 to give you 12.
Okay.
All right?
Okay.
Okay. All right. Any more questions? All right. No, I want someone to tell me what you think 4 is talking about. This thing is in its way. It's kind of simple, you know. It's just that we work out part already, you know. What this is saying is it add A plus B first, then add what? C to it. All right. Then know what you do. You add B plus C first. Then you what? You put A in front of it and add it and check to see if both are the same. All right. Let me give you a classic example. Let us work with numbers, like regular numbers. For example, suppose I have 1 plus 2 plus 3. All right. And I want to show that, you know something? What if I add the last 2? Would I get the same answer? Let me carry it over here because of the box. So look, what would happen if you're given 3 numbers? What would happen if you add the first 2 with the third one as opposed to adding the last 2 with the first one? You would get the same answer, not true? Because what's 1 plus 2? 3. What's 3 plus 3? 6. So the answer for the first part is 6. All right. And look at this. 2 plus 3 is what? 5. 5 plus 1 is also what? 6. So 6 is equal to 6. All right. And there's a special law. It's when they're equal. It's called the associative law. Or the law of association. So in other words, numbers obey the what? The associative law. So what we're trying to do, we're trying to investigate if addition of matrix. Because remember, you know, A, B, and C are not really A, B, and C. A, B, and C represents what? A matrix. So we want to investigate if the addition of matrix obey or disobey the associative law. Anybody following? Anybody lost?
I'm lost, sir. The part that you say you set out here 1 plus 2 plus 3 equal 1 plus 2 plus 3 bracket. So you're saying 1 plus 2 equals 3 plus 3 equals 6, right? So then you say 1 plus, or you put it that way, 2 plus 3 equals 5 and plus 1 equals 6.
You get the same thing on the left hand side and get the same thing on the right hand side. So
Okay.
because both of them are equal, addition of numbers obey the what? Associative law. So we're trying to investigate if the same addition of matrix obey or disobey the associative law. All right. So in other words, if I work this out and I get a matrix 1, 2, 3, 4, and I work out this over here, so and I get the same matrix 1, 2, 3, 4, then what? What's the conclusion? Addition. Right. Well, you have to be specific. You have to say, when I say it, what is it? You have to say, okay, addition of matrix obey the associative law. All right. I understand when you say what it means, you know, I know, but I just want you to say it in practice. All right. All right. Okay. So, well, we know what A plus B is, don't you? Let's go up top here. A plus B is actually this, right? So that's A plus B. I'm just going to copy that. Let me just delete this. All right, so what I'm gonna work out this first. So, boy, this box here is just getting to me. So A plus B that, and then what I'm going to do now is what? Add C to it, don't you? Where is C? C. All right, somebody quickly just work this out for me now, please. Just match it out. And tell me what you get.
9.
Hold on, give me. Oh, your connection is shaking. Continue.
8.
Negative
11.
Which is right. Everybody agree?
Yes, sir.
Right, so this is the what? This is the left hand side. So what we're going to look at now, we're going to work out the what? The right hand side. All right, so this might take a little bit more effort because we don't know what none of those are. All right, so I think what we should do is that we should work out what? B plus C first. All right, so quickly, can you do that for me, please? Add B plus C. Hold on, did I work out that? No, have that. So B. If you can't bother work out, then stop me, them stop me, like -2 plus. You can just use a calculator, It actually works out. All right, so this is what? B plus C. All right, so what I'm going to do, I'm going to put what? A in front of it. All right, so I'm going to have A. So this is A. That's A. All right, so B plus C. So this is B plus C. So somebody work out that for me, please.
Nine. Eight.
So the answer is the same.
Negative 11.
Answer is the same.
All right. Yes, you get the same thing, not true? So the left hand side is equal to what? Remember, the left. This was the left hand side, not true?
Yeah.
You know what? Let me change that color. Too much killing I go on. You know what? This is the right hand side. All right. So we notice left hand side is equal to the what? The right hand side. So therefore, addition of matrices obey the associative law. So we spoke about the commutative law, and now we'll talk about the what? The associative law. Are you guys following? Any questions?
So if in exam we would write the therefore addition of that, whatever.
I mean, what I tried. Well, yes, try to be as how I present it. You know, to be frank with you, let me tell you. Then I've never actually seen a question where they actually ask you to do all of this. You know, what they'll do, what I've seen they do is they will test your skills and find out if they're equal. All right, but I'm yet to see a complete question like this. You have to remember, you know, you see in CXE, the questions are not long, you know. They're not long because they want you to learn everything, so they cut down all of the questions. So they're not as long as this, but it's good to know these things. All right. So that's that for part 4. Any questions? Let's look at where are we now?
A, B.
Okay, right. A, B, and BA. All right. So we're at 5 now. What does AB mean?
A times B.
A times B. Right. So what we're doing right here now is what we call matrix multiplication.
Sir, sorry. Could you scroll up so I could take a pic, please?
All right. Here? Part 4?
Thank you, yes.
All right. Boy. Are you through?
Yes, sir. I said yes. Thank you.
Oh no, I thought you meant that. Okay. Well,
No.
All right. So matrix multiplication. So AB. So no, we're multiplying matrix. So we look at adding, and we look at what? Subtracting. All right. So no, we're looking at multiplying matrix. So as you said that AB means what? A times B. You're absolutely correct. All right. So let me put these things. Now, how we multiply a matrix is a little bit tricky here. It's not so straightforward as adding and subtracting, so just bear with me. So now there's a principle that we learn, right? Now, what you need to remember is that when we multiply matrix, we do so by no, hold on. Let me just say something. When we multiply a matrix, we multiply them row by column. How we multiply a matrix, class?
Row by column.
Right. That's what you need to remember, right? All right. So this can be a little bit tricky, sometimes a bit confusing, but I will try my best to clear up anything. All right. So so when you multiply a matrix, you need to remember something. Would you agree with me that this element here is hold on. All right, column 1, row 1. Would you agree with me? This is column 1. This element here is column 1, row 1, not true? This would have been what? Column 2. No, sorry. Yes. Column 2. Row 1. Am I correct? All right, let me try to explain. This is a matrix, right? This is a column, not true? And this is what? Another column. So this is column 1, column 2. This is what? Row 1. And this is what? Row 2. So I'm asking you, the element that's right here. It's the element that's right here. It is called what? Column 1 and row 1. See it? And this element right here, so would have been what? Column 2
and row
1. No, man, it wouldn't be row 2 because you're still in the same row.
Oh, yes.
All right. All right. What about this? Who wants to tell me what goes on here, sir? Is that column 1 same way?
And yes, sir. And then
Yeah,
row 2.
it's still column 1, but now it's what? Row 2. Over here says what? Column 2 and row what? 2. All right. All right. So guess what now? I'm gonna teach you guys. Hold on. I'm gonna teach you how to multiply a matrix. But guess what now? I want you to learn it in a methodical way. So I am going to show you how to get. Let me use this thing. I am going to show you how to get column 1, row 1 element first, then column 2, row 1 element second. So this one first, this one second, and then I'm going to show you how to get that one third, and the last one is down here. So, all right. So I want you guys to learn how to get this number first, then that one, then that one, then that one. All right. Otherwise, you might get still mixed up. Another one is get mixed up. All right. Are we clear? So the first thing that I'm going to show you. The first thing that I'm going to show you is how to get what? This one first. All right? You follow? All right, watch out now. So, how you multiply a matrix? What did I say? Row by column. So you see this row here? So it's going to be this row and this column to get what? That number. So it's going to be 4 4 times 0. So it's this 4 times this 0, and then no plus. Yeah, man, it's a plus. Plus 6 times 1 go down. All right.
Run that again, sir. Run that again, sir, please.
So it's this row. It's row 1. Row 1 is what? 4, 6. And what? Column 1, which is what? 0, 1.
0, 1.
So it's 4 times 0 plus 6 times 1.
Okay.
All right. We good?
Yes, sir.
Any questions? And then no. This thing is another way. All right. Then no. To get this number over here, so no. We're going to use the same row, 4 to 6, but we're not going to use the first column. Which column are we going to use?
The second column.
Right.
Negative. Negative.
Right. Who wants to tell me what I should write?
4
negative
times.
All right, hold on. One person. You want to use the raise hand feature? Use the raise hand feature quickly. right. Nobody's raising their hand. So, anybody want to participate? But because it was kind of confusing a while ago. So to give everybody equal opportunity, or to be unbiased. Nobody raising their hand. All right. So I will just proceed. All right. Yes, Nikisha, go ahead.
Okay, so we're trying to find column 2, row 1.
Right. We're trying to work on that element.
Okay, so would it be 4 times 1?
Hold on. Give me. All right. So it's 4 times. No,
No.
Remember, say. So why no man? The one that don't about
Column
yes, no.
2. Yeah.
Right. So it will be. But no man. This is column 1. This is column 1. So it will be. You're gonna use the second column. You're gonna use the second column. So it'll be 4 times -3. Is it?
4 times -3.
Right. So.
Oh.
Right. Second column now. And tell me the last part now.
2.
And 6, right? And 6
times -2
times -2. Why is that?
Why if me confused one more time?
No, it is confusing. I'm not gonna lie to you.
My God.
It is confusing. Everybody saw I get that? Any questions? Let me run it again. So it's this row with this column to get this. And then I use the same row with the second column to get this. And notice there's a plus. There's a plus between them. All right?
Sir, all look to me is like we're writing 7. First row, yeah, like it forms the number 7 if you draw it, come across, come down. If you get what I mean.
Okay. All right. No, you're going for a different level now.
I try understand. I try remember it.
You're seeing some other things that I'm not seeing. All right. Who wants to tell me what I should write for down here? So no. So let me give you a hint. We're not going to use the first row. We're going to use what? The second row with the first column. Who wants to take a shot at that? Please use the raise hand. Hold on. Hold on. Can you take down your hands for me, please? I don't know if your hands went up. If it's the first part. Yeah, just take the coordinate up. Put on your hand, please. All right. So using the raise hand feature, just raise your hand. Tell me if you want to participate in answering the other part of the question. Okay. Yes, Kristen. Go ahead for me, Kristen.
Sorry, so we're going to use the same column. So we'll use 0 and 1, but we're going to use 5. So would it be 5 times 0?
Mm-hmm.
Then we would have plus -3 times 1.
Right. You see that? So I'm using this row with the first column. And then now to get the last one, I'm going to use what? The second row with the second column. All right? So let me just finish it off. So it's going to be 5 multiplied by -3 plus -3 times
-2.
-2. All right. And your job now is just to work out. Once you get this, we're good enough. All right. All right. So then now we try to work this thing out. Well, 4 times 0 is 0. That's how you go. All right. 6 ones is 6. That's 0. That's what? -3. What is this? -12. A positive and negative give you a negative. 6 twos is also what? 12. So this is actually the O and O. That's what? Negative what? 24. This is what? -15. 2 negative give you a positive. So that's 3 twos what? 6. So that will give you negative what? 9. Yeah, that's the answer. So the answer is by the way, you guys understand what that's do right there, so? You want me to say it again?
Yes,
Say
sir.
it again.
All right. So look. All right. Hold on. What is 4 times 0? 0.
0, sir.
So that's 0 plus what's 6 ones? 6. All right. So what is 0 plus 6? 6. What's 5 times 0? 0. What's a positive and a negative? Negative. What's 3 ones? 3. What's 3 from 0? -3. What's that? What's 4 times -3? -12. What's a positive and a negative? This positive one is negative. A negative. What's 6 twos? 12. Your O and your O. Your O what? 24. What's 5 times -3? -15. What's a positive and a negative? Negative. What's 3 twos? 6. Oh, sorry, hold on. Sorry, negative. Oh, I didn't see this. So negative and negative is actually what? Positive. So it's -15 plus 6. All right, so you owe 15, you have 6. So you owe, you still owe. You owe 9. Let me tell you, so you can use your calculator to do all of this. It's right here, so with the bracket them, just use your calculator. Don't stress yourself.
Yes, sir.
Yeah, man, nobody stress yourself. So this is 6. -24. -3. -9. That's the answer. So that is A, matrix A multiplied by what? Matrix B. All right. Let me ask something. What's 2 times 3? 6. What if I spin it around? 3 twos. What you notice? We still get 6. So what can we say about multiplication of integers? Multiplication of integers obey the commutative law. So what if I spin around B times A? Because remember, A times B gives me this. So what if I spin around B times A? What would I get? Let us investigate. So that's our job. That's our next job. So what we're going to do is to work out B times A. So we put the B.
Sir, I'm lost.
Where?
At the top, where is where we do the work, you know, it said 4 times 0 equals 0. 6 times. Sir, I'm lost.
Were you in the class the whole time, or you just came back from somewhere? Because
I was here, sir. I just heard this, sir.
Yeah, but I'd explain it twice. What you don't understand? How I get these numbers?
I know how you get it, sir.
Oh, you mean how to work them out? How to work them out?
Yeah.
You have a calculator?
Yes, sir.
Let me.
So when you work out everything, this is the answer you get right here. You got right here. 6, -24, -3, -9.
Hold on there. I'm just seeing something. I'm just seeing something a while ago strange. Is that class? Okay, please move this window. I wonder if this is a solution. Alright, let me show you. Are you seeing my calculator?
Yes, sir.
Alright, look. So all you need to do is open bracket 4 times 0 close bracket plus open bracket 6 times 1 close bracket. And see there, answer is 6. Let's do one more. Let's do the one on the -24. Let's do this one here. So
Calculator looks so dark. How may I say some a blackness?
Not seeing anything.
You're not seeing anything?
No,
No,
it says
calculator.
big black something.
Oh boy, I don't know what's happening. Somebody screenshot.
Just go ahead. So you say 4.
Hold on. Somebody screenshot this and send it to me. Let me see. I just want to see. Whoa. Alright. Zoom is acting up. I don't know what the problem is. But it's not working 100%. Alright. It gone now? The
Yes,
thing
sir.
is gone. So I don't know. Come back now, not true?
Yes, sir.
Alright, so I don't know what's happening. Apparently, it's that little box thing there. When I open the calculator, it engulfs the calculator, the box. So I don't know. I don't know what's happening. Alright, so let me just work it out manually again. So 4 times 0 is what? 0? Right. 6 ones is 6. What's 0 plus 6? What's 0 plus 6?
6.
Right. What's 5 times 0?
0.
Right. A positive and a negative is a negative. What's 3 ones? 3.
3.
What's 3 from 0? Negative 3.
Okay.
All right. What's 4 times negative 3? Negative 12.
Right.
What's positive and a negative? Negative. What's 6 twos? 12.
12.
Your O and your O.
20.
Your O and your O. Your O 24.
Right.
This is negative 15. Two negatives gives you a what?
Positive.
3 twos. 6. Your O 15.
Understood.
Your O 15 and your P 6 is still O what? 9.
9. Understood.
All right, so what I want you guys to know is to work out B times A for me. All right, so let's give it a try. Let me put it right here so for you. That's B. And that's A. Let me give you 5 minutes. Boy, I never know such 3 hours fly so fast. All right, so 5 minutes for this. B times A. Let me tell you something, man. This thing takes practice, all right? So don't beat up on yourself too hard if you don't get it at the first time, all right? All right, so I think I would have found a way to unconventionally get rid of the dialog box. Oh boy. All right, in the interest of time, you see, because it's almost 9. And anybody want to go ahead? Who wants to use a raise hand feature? Just use a raise hand feature and indicate that you want to. Maybe not all of them, but probably 1 or 2 of them. All right, Kristen, is that it? Okay, go ahead for me, Kristen.
Alright, sir. So start with the first. You're going to have 0 times 4 plus -3 times 5.
Yes, correct.
At the next side, so you're going to have 0 times 6 plus -3 times -3. At the bottom now, so you're going to have 1 times 4 plus -2 times 5. And then you're going to have 1 times 6 plus -2 times -3. Right. At the top up there, so sir, when you're calculating now, we know that there will be 0 plus -15. So the answer would be -15. Then that would be 0 plus 9.
Hold on. Give me a minute. Yeah. Okay, yes.
So that'd be 9, sir, because positive times are positive, negative, sorry. At the bottom now, sir, we'd have -6.
Yeah, mommy, correct.
And then you have 12, positive 12.
Yeah, you're absolutely correct. Very good. Excellent. Good job. Yes. All right, class, are you following?
Yes, sir.
All right. So when you notice, this is A times B, and this is what? B times A. When you notice, are they the same thing?
No, sir.
They're not true. So what's the conclusion? The conclusion is A times B is not equal to B times A. So therefore, multiplication of matrices does not obey the commutative law. All right, that's the conclusion. So when they flip around matrices, you don't get them. They're not equal and multiply. But when you do the same thing with numbers, they're equal. All right. Okay. Any questions? All right. So we're almost at the end of the session.
Sir, you said something about some SBA.
SBA. Yes. All right. No, I wanted to check to see if the SBA, because some of you guys didn't put Wilmots on the title, so I just want to get mixed up, but we can, I can cross check it with the register I have, no big problem, but but definitely next week you will hear some positive feedback from me as regards to SBA, because I am actively working on them. The thing is, I don't want to. I'm trying my best not to give you feedback for 1 and 2 or 3 persons, and then say, "Sir, what about our group? Our group?" I want to do the whole thing one time, so nobody's pressuring me. All right. As a matter of fact, I would probably want to meet with the groups individually. I think we could probably. I think all of you guys would have created a WhatsApp group, right? And you'd have added me, right? Is that so?
Yes, sir.
Right. So what you could probably do during class next week, or near to the next 30 minutes before class is over, we could probably do a little group WhatsApp call, and I discuss to you what your grade is, what you get, or what the problem was, or what the situation is. All right.
Sir, that is going to be a problem for me because I do not have a phone.
Oh, you don't have a phone?
No, sir, my phone.
All right. So I could also we could do. For you, Kristen, we could you couldn't borrow a phone for that night, or you couldn't borrow a phone. Like,
sir?
You couldn't borrow a phone for that night.
For tonight?
Just for a moment.
Yes, sir.
Yeah. You could probably do that. All right. So next week. Oh, before I go, look. So you guys can do the rest. Let me share something. Watch here now. This is homework. All right. So we just successfully attempted part 5. Look at part 6. What do you think part 6 is asking us to do?
3 times BC.
Right. But guess what, I'm tell you what you're going to do. You have to be careful, What you're going to do, you're going to multiply B times C first. You get that?
And then you use the 3 and multiply.
Right, by everything inside. Right. Let me tell you what, or you could do this. You could say 3 times everything in B only, and then you multiply that times C.
Okay.
So let me say it again. 3 times everything that is in B only, and then multiply that product by C. Or 3 times everything in what? C, and then you multiply B times that. Or to me, this is actually easier. Just multiply B times C, and then multiply everything by what? 3. But this is what you should not do. Listen carefully. This is what you should not do. Don't say 3 times everything in B and 3 times everything in what? C. And then multiply it together. Don't do that. That's wrong. All right?
So you work out B times C and then you times it by 3.
Right. All right. What do you think C square means, class? Does it mean you're gonna square everything that is in C?
Yes, sir.
Yes.
No. You see C square? C square is actually, whoa, what is this? Hold on a second. All right, so C square, all right, I don't know what's happening. It's actually C times C. Oh boy.
Okay.
I don't know what's happening. C times right, C times C. So C square is what? This reminds us of something, not true? Which exam you do?
CXC. So,
Alright.
so sir, when you do that, when you say we do C times C, then we're gonna
Times it by 2. Times it by 2. And then put B in front of it and then what? Subtract it.
Okay.
Alright?
Alright.
Let me repeat. You're going to find C square. C square is matrix C by C. Put 2 in front of your answer and multiply everything by 2. Then you put B in front of that, subtract it, and you get your answer. All right. So come next class, this is what we're going to tackle. All right. So I don't want to come with and get 2 hands full. Do some work, show some effort. All right. And then on the last part, this is what you're going to do. You're going to multiply A times B, and then when you finish, you multiply everything by what? By C. You get that? So it's like you're going to multiply 3 times. So A times B. Oh, by the way, we just do AB a while ago, don't you? So that clear the thing. We do AB a while ago, so you can just use that. So just multiply the product of A and B times C, and then now you multiply B times C. Get your answer and put A in front of it, and you're gonna check to see if the left one is equal to the what? The right hand. If the left hand answer is equal to the right hand answer, then you could say multiplication of matrices obey the associative law. So we notice it obeys the what? For addition, not true? Addition of matrix, right? Addition of matrix obey for addition. Sorry, what I'm saying. The addition of matrix obeys the associative law. But does the multiplication obey it? We don't know. Let us investigate. All right. So I'm giving you 3 questions to look at. All right. All right. What I'm gonna do, I'm gonna send this document in WhatsApp so you can look at it. All right. I don't think the video will be